Okay, guys, we're rolling now. Okay, so everybody should have a piece of graph paper and a ruler, and we are going to do a little practice here together of graphing lines, because what we're going to be doing today is investigating how the equations of parallel and perpendicular lines are related to each other. Okay, so I have a few lines we're going to look at, give you their equations up here. And then we're going to graph these things together. So we're going to do y equals 2/3 x plus 5. We're going to do y equals 2/3 x minus 1. And we're going to graph y equals negative 3/2 x plus 2. Okay, now when I graph them, and we're going to do all these on the same coordinate plane. Okay, all together on the same coordinate plane. Now when I graph them, I'm going to use some different colors to help kind of emphasize some stuff, but you don't need to do that necessarily. Yeah? You may, just be quick. All right, so let's take this coordinate plane. Guys, quiet, please. I don't care. You're both being stupid. Stop it. All right, I'm going to try and make this thing 10 by 10. Yeah. Might need to expand it out a little bit. And I might run out of room going up here. I think I'm just going to make it up to 8 this direction then. But this should still be plenty of room for what we need to do. All right, so like I said, little review of graphing some lines. So the first one, go ahead and make this will be our red line that I'll do. So we talked about, at the end of the last assignment, you guys had to identify slope and y-intercept of that, of equations of lines. So for this one, what's the y-intercept? Yes, Savannah. 5. Okay. So that means on the y-axis, we start at 5. So put a little point right there. Bless you. Okay, so then, what's the slope of this line? Somebody else, Nolan? 2 over 3. Okay, so what that means is from that point, I can go up 2 over 3, and there's another point on the line, right? Okay, it's a rise over run thing with slope. Okay, so up 2, 1, 2 over 3, 1, 2, 3. There's another point that's on that line. And then using your ruler, you can make a nice, straight line across there. So something kind of like that. That's the first one. All right, I'll do blue for the second one. So now we're going to do 2/3 x minus 1. Okay, so y-intercept this time is negative 1, so we're going to start down here. And then same thing with the slope, right? From that point, up 2 over 3. So we can just count that. Up 1, 2 over 3, 1, 2, 3. So that also has a slope of 2/3. And then we can put that together. So those two lines appear to be what? Right. Parallel, okay? So take a look at What do you notice about their equations where I could just look at those and say, aha, I know those two are parallel? Yeah. Slope is the same. Okay. So before we graph this third one, let's just go down underneath this and write that down, because that's important. So parallel lines have the same slope. And think about how you use slope. Doesn't that make sense? It's rise over run, right? So it's telling you how far up and over you need to go to make it. So it's kind of like measuring the tilt of the line. Well, these two have the same slope, so they have the same tilt. Lines that have the same tilt, those are parallel. Okay, so it's that same slope that sets up that those lines are parallel there. Okay, all right, let's come back and do the next one here. I think I'll make this one purple. All right, so this one, different slope this time. Negative 3 over 2x plus 2. So we're going to start at 2. And this time, down 3 to the right 2. Okay, so go ahead and do that. Go down 3 from there. 1, 2, 3, and then over 2. 1, 2. All right, so let's connect those together. So we get a line that looks something like that. So what do you suppose is true about that purple line that we just made? Yeah, Nolan? It's perpendicular to the other two. Correct. So we have just now made a couple of parallel lines and a perpendicular line with the other two. Now let's go back to the original equations. We said for parallel, the slopes are the same. There's a relationship with slope again with perpendicular, but it's not that they're the same. It was a different slope this time. But what did I do to the slope to make it so that I knew it was going to come out perpendicular? Savannah? Did what? Opposite in what way? Okay, so there's actually two things going on there, right? The fraction flipped, and which is a reciprocal, right? I took the reciprocal and I made it negative. So I changed the sign, did the reciprocal. So we call that the opposite reciprocal slope, or negative reciprocal slope, however you want to say that. So perpendicular lines opposite reciprocal slopes. Okay, so flip the fraction, make it negative. If the original slope was negative, the perpendicular slope should be what? Positive, right? So if it started positive, the new one should be negative. If it started negative, the new one should be positive. The sign just changes, okay? So I always just remembered it as flip the fraction, change the sign. Got it, okay? So that's what we're looking for with parallel and perpendicular lines. So first of all, if I give you some equations of some lines, can you tell me which ones are parallel and which ones are perpendicular? Okay? Just by looking at their slopes. And then the next thing that I'd like you to be able to do is if I give you points that a line will go through, can you tell me which ones are parallel, which ones are perpendicular, that sort of thing. So those, you have to actually like calculate the slope first and then work the rest of the way through it. Okay, so let's try that idea here real quick. So let's see if we can identify which are parallel and which are perpendicular. So I'm going to give you some equations to start with. Let's make that a 12. Okay, so we'll say this is A, this is B, this is C, this is D, this is E. All right, so I got 5 equations there. I'll zoom that in just a little bit so we can see those better. So got line A, line B, line C, line D, and line E. And which ones are parallel, which ones are perpendicular? So let's try and get some people who haven't spoken yet today. One moment.
Excuse the interruption. We have a few announcements. Girl Scout Troop 30199 is doing a project collecting broken pieces of jewelry or single earrings that will make them into new jewelry and sell it for profits, benefiting orphans in South Africa. The collection bin is in the cafeteria during lunches. Please bring in any odds and ends you might have. Students, would you like to wear a hat to school? Tomorrow, students can wear a hat by paying $1 to donate. A dollar donation in support of Helen DeVos.
Start with the easier one here. Oh, yeah, question? Oh, hold on a second, because I'm going to ask specifically. So first question, which of these lines are definitely parallel? Anybody help me with those? And we get somebody who has not spoken yet. Yeah. Right. A and E, right. Okay, so, and we're going to practice here using the correct little notation. So A is parallel to E. Say it like that. Okay. Now, perpendicular. Again, people who haven't spoken, I think all 3 of you have today already. So you haven't yet. Yeah, go ahead.
Oh, I have what?
Oh, well then forget you. Somebody else. Yeah.
B and D.
B and no, those are not perpendicular. Now B and D, here's the thing. Look at those 2 slopes, because we're focusing on slope, right? Look at the slopes of B and D. They're opposite signs, but they are not what that they need to be? Reciprocal. So let's find some reciprocals in the mix. Yeah. B and C. Yes, those are. Okay, B and C, 1/3, -3, because 3 is 3 over 1. Right. So 1/3 is the reciprocal of 3. They have opposite signs. Yup, that works. So B is perpendicular to C. Those work. All right, any others we see in there, Jace? Say it again. I didn't hear the first one. D and E, yep, good. Yep, because we've got -1/3 and +3. And I believe there's one more set in there. Somebody who has not spoken yet. Yes. You haven't yet. Yeah, go ahead, Seth. D is perpendicular to A. Right. Okay. Feeling pretty confident with that? Okay. All right. Now, if we take a look at these where they're not all written out for you, but rather I give you 2 points that are on a line, and we have a whole bunch of those, can you go through and tell me which are parallel, which are perpendicular, and all that? All right. And I'm going to actually have you guys work through a question that's right on your homework assignment. Hint, hint. So you could just, look at this in your notes and copy it down.